So now we consider the question of simplifying a ratio. And there are several things that we'll want to take into account in order to decide whether a ratio is simplified or not. What does it mean for a ratio to be simplified? Well, in a simplified ratio, we would like to be able to write the fraction notation as an ordinary fraction. So in a simplified ratio, we would like all quantities to be whole numbers. And we would like the smallest whole numbers we can possibly have, right? So we don't want to have factors in common. So in fraction notation, a simplified ratio looks like an ordinary fraction in lowest terms. Now, two things to notice about this. Sometimes when we're simplifying fractions, it turns out that that fraction is a whole number. Sometimes when we're simplifying fractions, we decide we want to actually express it as a mixed number or a decimal. We don't do any of that with ratios. So, for example, if we have the ratio 4:1, we can't express that as just 4. Right? We need to name a number for each of the quantities we're dealing with. Similarly, if we have the ratio 1:2, we can't express that as the decimal 0.5. If we have the ratio 7:3, we cannot express that as the mixed number 2 1/3. If we regard each of these expressions as a fraction, then yeah, 4 wholes is 4. 1/2 is 0.5. 7/3 is 2 1/3. But if we're thinking of these as ratios, we have to leave them in a form where we can readily rewrite it using the word 2. 4/1, 4:1. 1/2, 1:2. 7/3, 7:3. So that's something to be cautious of when we go to simplify ratios. There's one other thing to be aware of, and that is units of measure. So for example, I might say, on a certain map, 1/2 inch represents 1 mile. And we want to write the ratio of real distance to distance on the map. That will be real distance 1 mile to distance on the map 1/2 inch. It would be incorrect to say 1 to 1/2. Why? Because this suggests if I have one thing, no matter what the size, I get half of a thing of the same size on the map. And that's no good, right? All right, let's say we wanted to simplify this ratio. I think the easiest thing is to write it in fraction notation. In my answer, I know I'm going to have miles to inches, so I'll set those aside for the moment. And then what? I'll have 1/2. That's a complex fraction. How do I simplify a complex fraction? Right, I understand this main fraction bar as division. So I'll have 1, I'll write 1/1, divided by 1/2. How do I divide fractions? Right, I write it as multiplication by the reciprocal. So I'll have 1 times 2 is 2, 1 times 1 is 1. And can I just write this as 2? No, I can't, can I? I have 2 miles to every 1 inch. Okay. In fraction notation, this is a fraction in lowest terms. In this notation with the colon, I see just whole numbers, and I see they have no factors in common. Now, if the units are the same, say we have 25 girls and 35 boys in a class, and we want to write the ratio of girls to boys. We'll have girls first, boys second. What are the units? What are we counting here? I think we're counting entire kids, right? So we have 25 kids to 35 kids. Notice how the units of measure are the same. We can think of those as canceling out. What does that mean? Well, that means we could write in different units here and the same ratio. Right, so we could, for example, instead of kids, write in buses full of kids. If we had 25 buses full of girls and 35 buses full of boys, and they're all the same size bus and they're all full, that would give us the same ratio as just 25 girls and 35 boys. The units cancel out if they're the same, which means we don't need to think about them anymore. And the reader can just fill in their own unit. How else can we simplify this? Well, in fraction notation, it's numerator to denominator. Let's see, I think these guys have a common factor of 5, don't they? 25 is 5 times 5. 35 is 5 times 7. We cross those off, and we're left with 5 over 7. So the simplified ratio is 5 to 7. Let me give you some of these to try. Suppose a certain recipe calls for 1½ cups of milk and 2 cups of sugar. Write the simplified ratio of milk to sugar. Pause the video and try this now. Alright, so we're going to have milk to sugar. The amount of milk is 1½ cups. The amount of sugar is 2 cups. Are the units the same? They are the same. So they cancel out. Now we need to simplify the rest of this. Is it already simplified? No, this isn't a whole number, is it? So we'll go to fraction notation, 1½ to 2. We understand the main fraction bar is division. So I have 1½ divided by 2. To do this division, I need to write both of these as improper fractions. I take my one whole thing, cut it into 2 equal parts. That gives me 2 halves. Plus the 1½ I started with, I have 3 halves. And divided by 2 whole things. So let's see, that's going to be 3 halves times 1/2. Multiply the numerators. Multiply the denominators. I have 3 to 4. The ratio of milk to sugar is 3 to 4. I'm going to have you try one more. Suppose Jim buys a 1.3 kilogram bag of rice for $4.55. Write the simplified ratio of rice to money in this situation. Pause the video and try this one now. Okay, so we want to write the ratio of rice to money. So the rice, I have 1.3 kilograms. The money, I have $4.55. That's $4.55, right? Are kilograms and dollars the same? No, right? So in our answer, we're going to need to keep the units, kilograms and dollars. Other than that, is this already simplified? Well, no. These aren't whole numbers, are they? So we'll go to fraction notation, numerator to denominator. Let's see. I want to get rid of these decimals. In order to do that, here I need to move the decimal point 2 places. Here I only need 1. 2 is more. I'm going to multiply my numerator and denominator each by 100. So we could do this just by moving the decimal points, or we could ignore the decimal points and multiply. Put 1 digit after the decimal point. Ignore the decimal points and multiply. Put 2 digits after the decimal point. Either way, we end up with 130 over 455. So that's now an ordinary fraction. Is it in lowest terms? Sure doesn't look like it, right? What common factor do we definitely see? we definitely see that these have a 5 in common. Let's see. 130 divided by 5. 5 goes into 1, not at all. It goes into 13 twice, right? Because 2 times 5 is 10. 3 left over. Bring down the 0. 5 goes into 30 6 times. How about 455? 5 goes into 4, not at all. But it goes into 45 9 times. Bring down the 5. 5 goes into 5 once. And that's it, right? So the common 5s cancel. And the question becomes, do 26 and 91 have any common factors? Well, 26, it's easy to see, is 2 times 13. 2 doesn't go into 91. Does 13? Well, a little bit of guesswork shows us. Yeah, it does, doesn't it? So 13 is a common factor here. We're left with 2 over 7. We're getting 2 kilograms for $7.